Welcome to Brain Vision.
We are told an egg is thrown nearly vertically upward from a point near the edge of a tall building, and that the egg just misses the edge of the building on the way down and passes a point 30 meters below its starting point, exactly 5 seconds after it leaves the thrower's hand. So to put this into math, we use the position as a function of time equation, and we know that the final position is negative 30. We can say that its starting point, we can call that 0. So then this is just going to be equal to its initial velocity times time minus 9.8 divided by 2, it's gravity divided by 2, which is 4.9, times t squared. And we're told that t is 5, and so solving, we get that the initial velocity is negative 30 plus 4.9 times 5 squared. All of that divided by time, which is 5. Solving, we find that the initial velocity must have been 18.5 meters per second. Now for part B, we want to find how high it rises above its starting point. We want to find the maximum height. So in order to first find that, we have to figure out how long it takes to get to the apex of its throw. And we know at the apex that the velocity is 0. So the apex of velocity is 0, and we know that the initial velocity is 18.5. So 18.5 minus little g times time, solving for time, and we find that 1.8888 seconds after the ball is released, it reaches its apex. Now plugging this time back into our position equation above, we find its maximum height is 31.4 meters. Part C just hammers this home some more, and it asks, what is the magnitude of its velocity at its highest point? And as we just said, we know that magnitude at the apex of its throw is the velocity is neither going up or down. So the velocity at its highest point is 0. Next, we want to find the magnitude of and the direction of its acceleration at the highest point. And its acceleration is constant throughout this whole problem. And that's just little g, so it's 9.8 meters per second squared. Now, finally, we want to draw a few plots. First, of the acceleration, first time. And we said that the acceleration is going to be negative 9.8, and it's constant throughout the problem, so it's just a straight line. Then the velocity versus time, the velocity is going to be decreasing linearly, starting positive. That's just going to be a straight line sloping downward, intersecting the 0 axis because it eventually becomes negative. And then finally, the egg's position as a function of time is going to look like a parabola. Which eventually goes negative because we're told that it ends up negative 30 meters below its starting point.